Hello everyone, I'm Cibaca Khandelwal. I work across the software, cloud, AI, and compliance driven projects, mostly focusing on a mixture of practical systems and governance. And that's what has inspired this session on synthetic data and scalable AI, enhancing model performance across the domains. Uh, just to give an overview, why synthetic data now? We are entering an age where AI depends on data more than ever, yet collecting it responsibly has never been harder. Privacy laws restrict what can be shared, labeling costs keep rising, and global events constantly shift what representative data means. Meanwhile, model keeps going. We have seen especially the large transformers and diffusion architectures demanding more diverse input. The result is a bottleneck, enormous model capacity but limited fragmented data. Generative techniques now fill the gap. Using advanced diffusion models, which turn noise into a structured example, and LLM based simulators, we can create realistic, controllable samples safely. Gartner 2025 forecast notes that almost half of AI teams now include data generation as the core workflow. It's no longer an experiment, it's part of the standard process. So let's move on to what actually synthetic data it is. Uh, what is synthetic data? It's the data produced by algorithms rather than collected directly from the people. Few examples include generative adversarial networks that has a generator and a discriminator against each other until the generator becomes indistinctly from reality. Variational autoencoders. These comprise of data into latent space and sample new variations. Diffusion models start from random noise and iteratively refine the structure, producing extremely realistic outcomes. And large language models can now simulate entire table summaries, contextual understanding, and dialogues. Together, these techniques expand the diversity of examples available for training and testing, giving us more balanced and bias resistant models. So, with this, would like to move on to the next stage, which is how do we evaluate how good quality of synthetic data are we generating? What are the factors that should be considered? Generating data is easy, proving it reliable takes work. So it's very easier nowadays with all the advances in the AI algorithms to generate new data. But how do we know that the data that we have generated has a good quality, both statistically and in terms of an expert review? So there are a few techniques which could be used in which this slide generates. There are four principles primarily. One, differential privacy, which formally anonymizes the ensuring that no individual identity is being revealed. There are multiple frameworks which support that. Transparency and lineage, which focuses more on how the data was generated, was it validated, for what use was the data being generated. The standard compliance standards and ethical governance. These two topics focus more on global norms, emerging use of synthetic data. There are different government AI acts which provide us with the guidelines, and then also having a fairness testing and accountability reviews in the end-to-end AI development lifecycle. So usually governance is more about credibility and providing transparency and validation so that we can trust the synthetic data that we are generating in. Moving on to the next important factor, which is structured and tabular data sets. So this particular topic deals with as we are coming across all the data in day-to-day basis. One of the most crucial steps is to structure and format the data so that the AI models can use them. This could be the spreadsheets, transactions, and records behind every enterprise systems. And this also what quietly drives the most applied AI applications. So this consists of few of the frameworks that we usually follow: conditional GANs and tabular relational data. These are mostly used to for the kind of data that are balanced, have different classes, relational tables, mostly focusing on relationship between the features. Tab PFN, this is trained over 130 million synthetic tables, showed how the pre-training on synthetic samples boost few shot accuracy. Even the unstructured domains, such as our finances, our threat detections, and video and imaging data, still rely on these structured metadata like timestamps, embeddings, and sensor tags. What we need is, when we enrich this layer, everything built on top of it, whether vision, text, and prediction, they all will become stronger. LLM prompts, diffusion models, LLM guided tabular synthesis emerges from these schema controlled pipelines. Moving on to, once we have understood the structured tabular data set, we would now like to understand how the synthetic data works across different industries. What are the actual practical applications for them, and what are the outcomes? So, moving on to the first, which is healthcare and life science sector, the major key challenge in this is private patient privacy and rare disease scarcity. So, we can get the real world data from day to day scans, but how can we actually utilize those real world data? So that's where synthetic application come into use. We use general adversarial networks, diffusion based models to generate the EHR and imaging data. This The outcome for this particular application is privacy safe data sharing with 50 to 20% of recall on rare class detection. So this can also generate some kind of uh, data which has not been found very frequent just by seeing few examples. Finance and risk, this focuses more, the major key challenge in the data sector for finance is regulatory barriers and bias auditing, because most of the transactions or financial data that we see might be falling under your normal category. And for that, you need to generate the synthetic transaction of what could be a risk data or a threat data. The best example for this is a FCA sandbox, which was published in 2024, where they utilized synthetic data and have provided a case study. This focuses more on fairness evaluation, secure analytics sandbox. The next most popular domain which we come across is vision and robotics. Obviously, due to the limited advances in terms of hardware and other computer requirements, the data labeling and data safety is a very expensive challenge that we face. So this has been mitigated in the synthetic application by 3D simulation. NVIDIA Omniverse and Unity Perception are the most common simulation platforms which have been used. And this focuses on simulation to real model transfer. So AI models are developed on both real and simulated data, and they use the concept of transfer learning, which in turn helps us to lower the labeling cost. Uh, Last two applications, one is in the manufacturing industry, which is also called sometimes as your industry 4.0. The major challenge here in terms of data is the sparse defect imagery, synthetic defect generation. So we perform synthetic defect generation for quality assurance. This helps us in faster inspection and reduces the false positive. And lastly, the language and agent models. So with this, since real world more users have started using this model, the problem that comes in training or making this model better is the toxicity and the alignment of data scarcity. So synthetic prompts are generated. There is a team of QA or red teaming, which keeps trying different prompts and different user scenarios to improve the model safety and have a wider evaluation and coverage across different jurisdiction. Moving on to the use case. So in this slide, I would like to deep dive into one of the most uh, utilized use case where synthetic data generation is helpful. And this example is more relevant because it also demonstrates how multimodal pipeline has been built. So, firstly, what is a multimodal data set? It is a data set where different formats or types of data are being addressed. It could be your imaging data, it could be your textual data, or it could be your relational data or structured data such as patient reports and so on. So in the healthcare example, we usually find all these three datas are combined together, and then the predictions are being performed to generate relevant results. So real data anchors your model distribution. Real data tells what categories or what type of data is to be generated. Synthetic data is usually used to expand the diversity safely. Clinical validation, the human in the loop is a concept in AI pipeline which has still been required because we still need the expert opinion to ensure that there is a realistic implication as well as ethical compliance has been followed. So, in such scenarios, as you can see it in the pipeline, you start with your real EHR and imaging data. You de identify the medical records to retain the patient's privacy. Then you curate an expert review and select the representative cases that you want to generate, which are missing and which will be helpful in making those predictions. Synthetic data is generated using all the techniques that we have seen in the previous slide. There is an expert who validates those data, and this is not a one time effort. It happens regularly as you update your data. You create a hybrid data set which is combining both real and synthetic data for training, and then that data is used for AI models to predict rare disease detection and n number of use cases for healthcare. So this is a really good example to study on how multimodal data is being used. With this, I would like to switch into a next topic, which is hybrid strategy. So as we have seen it in our examples, synthetic data is being used in varied number of industries. One important factor to remember is it would not work standalone. The best model to be built or the best data pipeline works when you combine both real world and synthetic data together. So, real world data will tell you the authentic patterns and ground truth. Synthetic data is usually used for scalability, privacy, where you have sensitive data and you want to hide in some of the information, and then also to manage the biases. We see that with all the advances of generative AI, there are a lot of biases as more number from different geographical locations, different domain in the society are utilizing those applications. It's very important that synthetic data mitigates those gap and is helping build a better model. Another factor, as we have already seen it in the healthcare example, is having a human oversight. Usually, the role for that human in the loop in this entire data pipeline is validation, fairness, compliance checks to ensure that the data that is being generated is replicating your real world patterns. It's not a data which cannot be useful for the use case and is not that it's deviating from the pattern. So this hybrid strategy, usually you see that there is around 70 to 90% of real data, which is used in applied AI systems. 10 to 30% is the synthetic data, and that's the highest accuracy and trust factor that you get. Obviously, the percentage would depend on use case to use case basis, but these are the ranges where you find the most optimal solution, where you can also use synthetic data and also gain highest accuracy for your AI models, thereby providing the results to your customers. Uh, Next slide. Uh, since now we have understood the entire process and different terminologies across synthetic data, I would like to bring our attention to what we call as beyond training. So once you have generated the synthetic data, you have utilized it for your use case once in your life cycle. How does then the synthetic data, is that the last step where synthetic data is just utilized one? How does it work in the real world AI application? So generated data in today's world in 2025 supports every stage of your AI life cycle, not just training or validating or increasing your data set size. It is used for your evaluation and safety testing as well. Like I mentioned, there is a concept of red teaming for language models with all the new advances in the large language models such as ChatGPT, Claude, Gemini models, DeepSeek, and advances happening in generative AI. It is also used for reinforcement learning feedback, where you can see examples such as vision, robotics, game engineering, developing characters for the games. So there are multiple use cases where synthetic data is usually used. Uh, One concept which is reinforcement learning feedback. That particularly deviates that once you have created a synthetic data, you have created an AI model, it has given you the results. The cycle does not stop there. It's a regular training, evaluating, alignment, deployment, feedback, retraining, and then feeding the information again to the training data. The reason this is a very important and a critical use case is because once you have used a synthetic data, after a few time, or you might come across more use cases where you'll update your AI model, or there would be some biases which might have been detected, or some particular scenarios which might not work. So it's very important that as you do it with your real data lifecycle, synthetic data also follows beyond training, and it keeps updating based on the feedback that has been received. So this is a very important stage, which is a feedback loop from all the models that we have discussed until now and across all domain applications. Uh, with this, now since we have understood what are the different terminologies within the synthetic data of applied AI models across different domain, one very important factor that we might have used is how do we validate or how do we quality assure that the synthetic data that we are generating can be trusted and is following the guidelines that we need for our AI models. So validation is where credibility comes from. We do have different ways in which you can validate the data. Currently, here I've listed four different examples. One is the statistical method. There are 4 to 5 statistical methods which are usually used if you have an understanding of what your real world data should be versus what your synthetic data generated these are. So statistical is one. The second way, as we seen in the healthcare example, is expert validation, where you have domain specialists who will access how the realistic the data was, how biases were done. Another factor to this is also testing your data more, providing it more test scenarios, different types of users testing it. And then there is an automated pipeline. So this was a new concept which was introduced called as GAFI 2023. That is a case study and a paper on that, which tells you how to automate these dynamic filtering pipelines, which will filter your synthetic data and validate it for you. And then the trusted outcomes based on real world, deploying your model in the real world scenario after you have done enough testing, so that based on your real world experiences and going through the feedback loop cycle that we just see beyond training, the model keeps improving. So the goal here is just to make we have a quantifiable trust factor. We validate the data by different mechanisms so that it is a governance ready synthetic data. So yeah, with this, these are the most concepts that we have seen. Moving on from synthetic data, if we look into AI model, if we just move towards how this data is being utilized into an AI model, we have already discussed that we need to do a recursive training on synthetic data so that there is diversity, the biases are mitigated, the validation is done, and based on the feedback that is provided. But we cannot forget that every technology has its own failure modes. One of the main important concept here is called model collapse, where a model starts training on its own generated outputs repeatedly, and it loses the diversity and drifts towards generic patterns. You can look at as you can imagine it like making a photocopy of a photocopy. Each iteration blurs out the details. So to avoid this, we do have to anchor new training rounds with real samples. It's not that the further training will just rely on the synthetic data. Refresh the synthetic data periodically and monitor the diversity metrics. Document the lineage. So every data set has a traceable version. So you can detect those failures once you have accounted it for, and keep adding simple checks to keep the data healthy and model outburst. Here, I've also provided few mitigation checklists that we usually take into account when we build such pipelines, uh, which can be used on regularly basis, and those mitigation steps could be added. With this, I would like to suggest some of the synthetic scalable ecosystem. So we have gone through the training loop. We know that how these pipelines are been built. I would also like to provide some open source tools which everyone can use and try it on in this field of synthetic data generation. Uh, Few of them are scalable synthetic ecosystem. So one is you complete your feedback loop, you integrate it with your MLOps pipelines with versioning and audit logs, just as you do it for your code. And along with that, you can use these libraries also to experiment. So just try to experiment some of these engines and provide your feedback and learn from them. So that would be a very good use case. Lastly, before we close, I would also like to move on to the next topic, which is what's in the future for synthetic data. We have seen that day to day agentic AI, generative AI models, lots of different terms are evolving at a very faster pace and an exponential speed. What we see is the rise of synthetic first mindset. Instead of collecting first and training later, we try to simulate first to learn safely. Federated synthetic generation is a very important concept which lets team to collaborate across borders without moving the private data and maintaining the privacy. Lots of research at major AI conferences such as NeurIPS and Fact 2025 shows how transparency standards are emerging for generated datasets. Goal is not to replace the reality, but to extend how we explore training models in a safe and a controlled environment before deploying them to the world. Lastly, I would like to just share that some of the topics that we have not covered in today. One of them is the real time synthetic data generation, jurisdiction specific regulations vary by region, interactive agent simulation. This is a very future research area. Mostly currently, you might see this in day-to-day language models or game engineering or robotics and vision. And a very important factor which is rising is ethical review and continuous validation. They do remain mandatory. So this was an overview of how synthetic data could be generated. Lastly, in my last slide, I would like to just share a few of the resources or references that I have mentioned during this presentation. And few of the points that I would like everyone to remember, which is generative data is becoming a core layer of AI infrastructure. It helps us train faster. Uh, it is more helpful if you start small, augment it within your next project for 10% of generated data and see how the performance and fairness change. So thank you for your time and for helping shape AI that's both innovative and responsible. Thank you.